Hello, today we're going to talk about nuclear chemistry. Nuclear chemistry is the part of chemistry which study reactions involving changes of atomic nuclei. So, you know that nucleus contains protons and neutrons. So some of them are stable and some of them are not stable. If they are unstable, they emit particles. So they can produce electromagnetic radiation, and usually it happens spontaneously. So it depends on what type of nucleus we have, and different types of nucleus can emit three types of radiation. So there are three types of decay: alpha decay, beta decay, and gamma decay. Right? So what is alpha decay? Alpha decay is a decay when nucleus emit pretty heavy particle, the particle which has two protons and two neutrons. So two protons and two neutrons. So together, this particle has charge 2 positive and mass 4. So, and you know that 2 charge and mass equals to 4 has helium nucleus, right? So we can use this symbol alpha, or we can use this symbol helium to show alpha decay. So example, if we have uranium atom with atomic number 92 and mass number 238, and it is known as alpha emittent. So we will write this equation like this. So if it is alpha, that means that helium or alpha particle is producing, right? So 2 atomic number and 4 is mass number. And the point is that the mass and the charge have to be the same. So if here we have 92 atomic number, that means that we have 2 protons in this, 92 protons in this nucleus, 92 protons. Here already 2 protons because it's alpha decay. Yes, and so this particle, which is created here in this reaction, has 90 protons. So its atomic number is 90. And what about mass number? 238 was mass of uranium and 4 is mass of helium. So the new particle will have mass 234. How to check yourself? Are you correct or you're not? So you need to add subscripts. 4 plus 234 gives us 238, and if you add 2 and 90, you will get 92. After, you need to go to periodic table, and you have all of you have them. So, and what I'm going to look for. I'm going to find the element with atomic number 90. So at the last row, 90 is thorium, the element thorium. So this is the example of alpha decay. So once again, alpha decay when unstable atom, usually it's very heavy like uranium, emits alpha particles, and each alpha particle is helium nucleus. Okay, so, and please don't forget to add subscripts because charge or mass should be the same. Okay, let's jump to beta decay. Beta decay, it's another type of decay when unstable atom emits beta particles. And beta particles, they are similar to electrons. So, and you know that electrons have mass equals to 0 because it's so small comparing to proton mass or mass of neutron, and it has charge 1 negative. So you can use both symbols, beta or this symbol. Both are correct. So beta particle, and as this particle has no mass, 0, that means that mass number will not change. Okay? How you can ask me, okay, we were talking about nucleus decay, but electrons are not in the nucleus. They're outside of nucleus, correct? Yes, and you're absolutely right. How a nucleus can produce, how nuclei can produce electrons? There are two types of particles inside nuclei, protons and neutrons. And neutrons is a little bit heavier than protons. Why? Because it can produce protons and electrons. So sometimes in unstable atom, neutrons decides, oh, I don't want to be neutron anymore, so I want to be a positive proton. But to become positive proton, it needs to emit one electron, and this is a beta particle. So this is the example. Thorium, the element with atomic number 90 and mass number 234, is better, has the way of beta decay. So beta decay. And if you know the type of decay, you start with this particle. So if it is beta, so you can write beta. Or you can write here electron. The same. You don't need to write both, okay? Just one symbol. Choose one. Okay. And what's about atomic number? Will it change? Yes, it will. Here we have 90 protons, okay? And I'm going to write it down, 90 protons here. But one neutron becomes proton and electron, right? So in the daughter nucleus, it will be one proton more, so not 90 but 91. Okay? But what about neutrons? So if a parent nucleus had 234 mass number, 234, that gives us 234 minus 90 equals to 144 neutrons, correct? But don't forget, one neutron decided to become a proton. So that's why it's not 144, neutrons in the daughter nucleus, it's 143. And if you add this number and this number, it will be still 234. Okay? The mass stays the same. So beta decay. Beta decay, parent nucleus produces electron and number of protons in this nucleus becomes bigger and number of neutrons becomes smaller. Okay, so what we put here, so thorium 90 and 234, and we will have the daughter nucleus 91 and still the same mass 234, and I need to add symbol here, and periodic table will help me with this, so it will be, okay, let's see, Pa, palladium. Okay, so this is beta emission. Okay, gamma emission. Gamma emission, gamma radiation is pure energy, no particles, just pure energy. As we discussed during the last class, excited states and ground states. And I gave you an example that when atom gain extra energy, that this atom can jump into excited state, right? So, but it's very unstable, and out of excited state, atom wants to return in a stable state. So that's why some unstable nucleus, they have usually they have too much energy inside. That's why they're unstable. And number of protons and neutrons inside these nucleus don't change, but their level of energy is changing. Their atom, the nucleus, becomes more stable, releasing extra energy. So let's say polonium can produce gamma radiation. So you can use this symbol, and no charge, no mass. Gamma, it's not particle, it's energy. No charge, no mass. That's why we will have the same atomic number here and the same mass number here. And it will be still polonium, but with less energy inside. Okay? So the way why actually some of isotopes, some of elements, some of atoms decay, because there is a law, unstable nuclei tend to become more stable. And there are three ways to become more stable. Or alpha decay, or beta decay, or gamma decay. And I underline this. The sum of the mass numbers and the sum of the atomic numbers must be equal. The sum of the mass numbers and the sum of the atomic numbers on the other side of the equation. Okay, let's do concept checking. Radon 222 is an alpha emitter. So alpha, and alpha means this symbol or this symbol. atomic number 2 and mass number 4, because this particle has 2 protons and 2 neutrons. So, and we will start with symbol Rn. This is one of noble gases which is very unstable, and sometimes you can you might listen about radon level in your basements. So sometimes you need to check the level of radon in your basement, because it's a very heavy gas, and it's naturally creating by Earth, and because it's very heavy, so it stays in the basement, and it's not very good if you spend more time, a lot of time in the basement. If so, you need to check the level of radon. Okay, but periodic table will help us. So we will find this symbol there. Mass number is given to 22, and atomic mass is 86. Okay, I will get this atomic mass from periodic table. So I found this symbol, and I got this atomic number. So decay, alpha emitter. So alpha particle, helium nucleus, 2 atomic number, 4 mass number. And you know, the sum of the mass numbers and the sum of the atomic numbers of one side of the arrow, that means here to the left, must be equal the sum of the mass numbers and the sum of the atomic numbers on the other side. So what should I do? 86 here, 2 here, that gives us 84 here. 2 plus 84 gives us 86. We are good. It's correct. So 222, 4 has helium. So that means 218 here, and this is a new particle. The daughter nucleus is a new particle. So in periodic table, find please element with these numbers. So it's polonium. Okay, and degradation product will be polonium. Okay, let's do another one. Phosphorus, 32. So phosphorus, and you know already the symbol is P. Find this symbol in periodic table. Its atomic number is 15, and mass number is given here. It's isotope. So 32 mass number, atomic number is 15, beta emitter, right? What does mean beta? Beta means that this atom, this nucleus, will emit electrons. So electron, no mass, 0 and minus 1 charge, right? Mass will be the same, 32, but what with charge? You need to add something. 1, 16. You will get 16 here, and that will be sulfur according to periodic table. So, and I'm going to check. Minus 1 plus 16 gives us 15 anyway, so we did correct. The next one, iron 59 is a beta emitter. So iron, this symbol 59 here. Oh, I'm sorry. No. Так, I need to. Okay, I will start again. So iron 59 is mass number. Please don't make the same mistake, okay? And in periodic table, we can find its number, it's 26, beta emitter the same. So we can use this symbol. And I'm showing you the different way of creating an equation. Plus, mass will be the same, 59, and atomic number is going to be more by 1. It's 27. And in periodic table, we can find it's cobalt. Okay? And another one, iodine. And this is symbol 125. It's mass number, and in periodic table we find its atomic number. It's 53. Gamma emitter. So we can use here like this, symbolize this symbol shows us that this is a lot of energy inside. It's a kind of excited state for atom. It's gamma emitter, right? So gamma means that energy, it emits energy, release energy, right? And beta emitter, and it produces beta particle, no mass and -1 charge. Okay, and their daughter nucleus will be the same mass, 125 and 54 atomic number. And in periodic table, we can find it will be 54, another noble gas, xenon. Okay? Okay, so degradation products, it's here, xenon. Okay. We can do more examples and you'll understand it's better. So alpha emission, and I would suggest write it down. If you see alpha, so just write down here helium to atomic number for its mass number and start equation. Polonium produces 2, 4 helium, right? So the degradation product will be 82, its atomic number, and 206. And periodic table shows us that is lead, its symbol. Okay, beta emission means that parent nucleus produces or emits beta particle, which is electron. So I can write down here no mass, -1 its charge. So sodium, electron here, and we will get the same mass number, but we will get atomic number 12, and it gives us magnesium. Okay, the next one, alpha emission. You can pause actually this lecture and try to do by yourself, and then you can play it and check if you were right. So that is the way to watch video lectures too. So alpha emission, so alpha particle, 2, 4 plus, so it will be 218 and 84 here. That gives us polonium. Here, iron, beta emission. Electron here, and 27 and 59. Mass is still the same because it's 0, no mass here, and it's cobalt. Okay. So the next one, lead. Lead alpha emission, that's why it produces helium nucleus, and what we have here, so 28, I'm sorry, 82 minus 2, we will get 80, and here we will get 202. And in periodic table, the element with atomic number 80 is mercury, Hg. Okay, uranium, alpha emitter. So alpha, alpha particle, okay, and gives us degradation product 90 here and 234, and you already know it's thorium. And beta emission for phosphorus. So beta, it's electron here, and degradation product or daughter nucleus 16 and 32, and that gives us sulfur. Okay, and gamma emission, you see, this is excited state for iodine. So gamma, pure energy, no particles. So and everything will be the same, 125 and 53, and still iodine because this atomic number is not changing. Okay, and the last what you need, what we are going to do together. So it's completing the following nuclear equation. So we have potassium here, and it's number 19, and you can see the particle, the type of emission is given already, so it's shown here. You need to add something which is missing here, right? So you can see it's beta particle, so it's electron. That's why we will have here the new one, degradation product with atomic number 20, and the mass will be the same, and it gives us calcium. Okay, so uranium, and degradation product is thorium. So 2. Why 2 here? Because I need 92 at the right side of equation here, and 4 here, that gives us alpha particle or helium. You can see nothing changed here. 4499, that means it's a gamma decay. Okay, so here we have alpha particle and 92 here, and 235. Yes, correct, and that gives us uranium. And uranium, you can see this is example of isotopes. So still uranium, because it has they have the same atomic number, 92 and 92, but different mass because they have a different number of neutrons in their nucleus. So isotope, I just remind you. So it produces a degradation product is neptunium, so that's why here we need to put -1, and mass will be the same, so 0 here, and this is a beta particle. Okay, and lithium 3 2, that means that we have 1 here, correct, and 6 and 4 here gives us 2 here, right? So this is our alpha particle, and this is the new nucleus, new element. Number 1, it's hydrogen, and C, it's isotope is heavy isotope of hydrogen because usually hydrogen have a mass number equals to 1, and this is heavy isotope. Okay, so uh, penetration power of these three types of radiation are different. Less harmful is alpha decay, alpha radiation, alpha particle. It can be stopped by piece of paper. So it's very easy to stop. The next one, beta decay, uh, pass through paper, but it can be stopped by aluminum foil, for example, and you can see, so beta, see ray of beta particles, and it shows like it is stopped by aluminum foil. But the most dangerous, the most harmful rays are gamma rays because they require to be stopped. They require concrete, lead, or heavy something stoppers. Okay, so this is the example of concrete. So and gamma rays actually. Were the reason of a very dangerous influence of Fukushima or Chernobyl. I think you've heard about them. So it's pure energy, but still very dangerous. So you need to be very attentive to use it, and there are two ways of always there are two ways for using energy, peaceful way, like electro stations or power sources, or it can be like atomic bomb, right? So it can be used in different way, but the humans need to think it very thoughtfully. So, and we need to answer these three questions, and we are done with this handout, and you will need to do these practice problems by yourself. Okay, so beta particles are identical to, and you know that they are identical to electrons. The second question, the most damaging nuclear decay to the human body is, and we just discussed it, it's gamma decay because it's pure energy, and to be stopped it needs lead or concrete, something very serious, very heavy. Alpha particles are identical to, and you know the answer, it's helium nuclei. Okay, so we're done with this part. The next one, practice problems, you're gonna do by yourselves. And please, after you're done, scan your handouts and download. And after, I will grade them. Okay, so good luck, and we'll see you next Tuesday.